Hi everyone, today we are going to be taking a look at all of the different forms that we've talked about solving systems of equations by and doing some work to decide how would we decide a method that we would want to use to solve it. So your foldable you should have over here on the left. Remember, you're cutting along the dashed line and then folding and gluing where it says glue here. Okay, but the three options we've talked about with solving is graphing, substitution, and elimination. And so instead of it just being, we're focusing on graphing today, so solve by graphing today, it needs to be more of a, we're given a system, we have two equations, we have two variables. What method do you want to choose to solve it with? And it's not even necessarily what method I would want to choose to solve it with. So as a teacher, we might choose a different approach than you might choose. And there's nothing wrong with that because as teachers, we might choose different approaches ourselves. So instead what we want to sort of do is look at each sort of category and point out some key features that might direct us one way or another. So some things will be things we've sort of mentioned as we've gone through, and some things might be completely new. The other thing you have to remember is right now I'm just giving you information. So these are things that I'm noticing and I'm pointing out. But if you're sitting in class or if there's something you notice or you point out, there might be other observations or other notes people might make. So your observations might be different than mine, and there's nothing wrong with that either. So some of the things for solving by graphing that I tend to look to, okay, is I tend to look and see is if both equations are solved for y. Okay, not just one, but I'm kind of looking to see if I see that in both places. Okay, another thing that I might be looking for is that I want to see some small numbers. I don't want to have to draw a graph that's really big. Okay, so if I'm seeing 50 in the problem, if I'm seeing 28 in the problem, really honestly, if I'm seeing 17 in the problem, I'm not going to go to graphing. Okay, I'm not going to go to graphing unless those numbers are really, really stinking small and they're both already solved for y. Because the reality is that while I'm providing you with a coordinate plane the majority of the time, that graph isn't always just floating around for us to use. So you might probably have to draw a graph, and that makes it a little bit more work and effort. So remember when we're solving by graphing, if we did, okay, this one has them both solved for y, we have small numbers, this might be one that we lean to solve by graphing. Remember, if that's the approach that we want to take, our job is to graph them both individually on the coordinate plane and to see or to find where they intersect. So if we look at this first equation, we would say that it has a slope, an m value of 1, and a b value of -4. So over here on my coordinate plane, I would go to -4 because we start with b first. My slope is +1, so I'm going up 1, right 1. And then we said, right, we'd want to make enough points that we're going to be able to find where these two lines intersect. Okay, then we'll go to the second equation. And we're going to find the m and the b value of that one and sort of graph it right on top. So this one has an m value of -2 and a b value of 5. So I'm going to start at 5. Then I'm going to go down 2 over 1. So those intersect right here. And so I would say this has a solution of 3, -1. Or x is 3 and y is -1. Now, substitution, we might have some different key features that we're looking for. So again, I'm picking out one that I would tend to solve by substitution, and then I'm going to look for some key features that I would probably notice. So ways that I tend to look for that I'm solving for substitution is that I have one equation that's solved for either x or y. Now, keeping in mind that for me, when I say one equation, that could mean both equations are solved. So this would technically have one equation that's solved for x or y. And realistically speaking, I would probably more likely solve this first problem by substitution because I personally hate making a coordinate plane and graphing. That's not something I enjoy doing. So again, when I say this one equation, maybe for you, you want to put in here that it's at least one. Maybe when they're both solved, that's a route you want to go to. But maybe you're saying, nope, I'd rather stick with graphing first, and so that's the route I'm going to go. Again, that's a personal preference. Okay, so reminders for substitution: when we find that one variable that does say x or y equals, we're sort of taking that and replacing it into the other x value. So that x value is going away, and in its place we're putting that y minus 4. And so we'd have a new equation that says 2 times y minus 4 plus 3y equals 27. And we'll go through and we'll just solve this like a regular multi-step equation. We're combining our like terms, which are on the same side, so we can combine them with the same sign. Now, once we get this y value of 7, remember we're not finished there because we need to find our x and y value. So we'd still want to take that y value and plug it in over here. And so we'd say x equals 7 minus 4. And so we have a couple ways that we could write our answer. We could write it as an ordered pair of 3, 7, or as x equals 3 and y equals 7. Now, you might say elimination is something that you like more, and so maybe you're putting more reasons that you want to solve by elimination or more things that you notice. Maybe elimination isn't something that is your favorite, and so you're trying to do elimination as a last-ditch effort. Okay, again, that would maybe depend on you personally and what you prefer, but maybe we're looking for things like the variables being stacked on top of each other. Okay, so we're going to see all the x's on top of all the y's on top of all the constants. So if we're solving by elimination, right, we said our objective is to get them to have a matching coefficient. So if we look up here, right, our x's currently don't match, nor do our y's. So we're going to have to multiply one of them to make them match. So maybe what we could do is multiply this coefficient of a 1 by a 2. And that would still make them be the opposite sign. So we'd have a 6x minus a 2y equals a 4. And a negative 8x plus 2y equals 4, right? We can now add these straight down. Our y's are canceling out. So we get negative 2x equals 8. Again, we're not finished. We need to take that value and plug it back in to find its other one. Remember, with elimination, that's a little bit more work. So you could choose either equation you want. I think I'll choose before I multiplied, because that's where I sort of see the smallest numbers. And so my final answer will be negative 4, 14. Now, we then have a variety of problems over here where we would want to make decisions about how to solve. Again, the key piece being here that what you choose might not be what someone else would choose. So for example, right off the bat, looking at this first problem, this has them both solved for y, but it also has at least one solved for y. So while one person might choose graphing, another person might choose substitution. Now, to go even more out on a limb, technically speaking, our y's are stacked, our x's are stacked, our constants are stacked, so we really could solve this by elimination as well. These aren't opposite signs. We could multiply one of those by -1, and we could go elimination as well. So that really might depend on your personal preference and what you want to pick. Okay, on our second one here, so I see these nice and neatly stacked. I notice that I already have a matching coefficient, so elimination is what tends to jump out to me here. Okay, but someone else might say, well, I see this x and I could solve for it, and therefore I could make this be substitution. Again, either of those approaches would be fine. Now, one of the things that does tend to throw students off is that this isn't in that nice, neat standard form with the x being first. That doesn't change anything about elimination. These are still the opposite signs, and we can still go straight down. So we could still add that straight down and just say 6 equals 3x, and those y's cancel out. and then still plug back in. So don't let that really change your mind just because that's in a different order. It's still meeting that nice, neat, stacked criteria, and so that still works. On our third one, okay, when I initially look at this, I see one variable that solved for y, and so I might jump towards substitution. But another student might say, well, it wouldn't be that much work for me to solve by subtracting that 3x over, and I can make them both be solved for y. The numbers aren't that big, and therefore I might go with graphing. Again, same as I've been saying, doesn't matter. Okay, so either of those options that you might be choosing would be completely appropriate in this situation. Now, our next one gets a little bit more tricky. What do we do when we aren't really matching any of the formats? Okay, so if we look at this, do we see both of them solved for y? No, we do not. Do we see one of them that says x equals or y equals? Nope, we do not. Do we see both of them in a stacked position? No, we do not. Okay, so when we're outside of any of those norms that we've seen, it still falls back on that idea that our job is to make it fit one of those norms. And there's multiple approaches we could take to that. Okay, some of us might decide, well, it wouldn't be much work to solve for y, and I could go the route of substitution. Some of us might say, well, it's easy enough for me to add this y back over. That kind of goes against everything we've normally done. But if I move that y back over, I then end up in a stacked situation, and that would then give me elimination. Okay, again, that's coming down to a preference of what you see and what you might like to do the most. There's one other thing that I sort of want to point out that might be a piece that differentiates what method we want to choose. When we look at this one, this last one here, we might look at this and say, well, they're both solved for y, so I could use substitution because at least one of them are. And you would be totally justified. You could solve this by substitution. The one catch that we would then have, though, is that we have this fraction of -1/2. Mathematically speaking, I'm comfortable working with that 1/2 all the way through, and so that doesn't really tend to throw me off or be an issue or dilemma for me. However, you might say, ooh, I really don't know about that. I don't like that fraction. Is there a way I could work around that? And one thing that we know is that a slope of -1/2 isn't an issue. And since these are both already solved for y, maybe it might help us to solve by graphing. Now, like I said before, it does still leave us a little bit in this world of the reality is a coordinate plane isn't always just straightforward sitting around waiting for us to use. We might have to do a little bit of work to get that coordinate plane there. So we might have to draw some things out. So on this first equation, right, our slope is -1/2, our b is 9. So we need to make sure we're at least drawing this well enough that we're keeping track of all of those points. So I'm starting at 9 and I'm going down 1, right 2. Down 1, right 2. Down 1, right 2. Now my dots might not look perfect, but again, keeping in that idea of down 1, right 2. Okay, if I'm starting here at 2, then I'm going up 3 over 1. Up 3 over 1. So I can at least put together that this intersection point right here is at the ordered pair 1, 2, 8. If you don't feel like you can draw your coordinate plane and make your points well enough to be able to do that, then you might not want to choose to solve by graphing unless a coordinate plane is easily accessible.